A very pleasant good evening, everyone. I'm Gurtej from Board Infinity team and welcome you all to this session. Get prepared for the FAANG interview before the graduating. Yes, it's a FAANG, Facebook, Amazon, Apple, Netflix, Google companies. I guess everyone is ready and very excited about this workshop. For more videos like this, please do like and subscribe to Board Infinity channel. And I'm looking forward that the audience is now very excited and waiting for the session. So let's without wasting time, I would love to welcome our coach, Mr. Rahul sir, who is having more than a 3-year experience in specific software development domain. So thank you so much, sir, for connecting with us today, and we are good to go now.
Hey, hi. Thanks for the opportunity. Okay. Uh, so fine. Okay. So let's start for the session. Fine. Okay. So the very first thing is who all the FAANG companies we have. Like I hope all of you knows. But before that, let us discuss the agenda for today's session. So initially, we'll see the FAANG companies. After that, we will see what is the most asked topic question, right? The topic which is most frequently asked, right, in almost all the FAANG companies, and I will say in almost all the top companies, right? And why the topic, like whatever topic I will be discussing, why it is important, right? Why it is asked, I will talk about that as well, right? Then we will pick a pseudo problem on that particular topic, okay, and then we will see the implementation along with the detailed explanation, right? I mean, line by line explanation for that particular topic. Fine. So, as we know, this is the FAANG company which we have, right? I mean, the companies we have Facebook, Amazon, Apple, Netflix, Google. But yeah, apart from this, there are multiple, great companies which are coming out there, right? So it's not only restricted to FAANG. There are multiple companies, right, which is, I will say similar to FAANG companies, like a software developer get, equal opportunity, equal, I will say, pay. Along with this, I mean, similar to this FAANG companies, right? So whatever the interview process is there for the FAANG companies, right? All the interview processes, like they have different strategies for interviewing their people, right? But for most of the interviews, if you see, or you will see the review, or you will see the most asked interview questions for these particular companies. That there is a topic which is dynamic programming, which is asked the most for to the interviewer, who basically go for interviews, right? So what is DP, why it is asked a lot. By DP I means dynamic programming. Why it is asked a lot, right? We will talk about this, right? So if you are from colleges, or if you have been into your colleges, you must have heard that whatever company come to your colleges, they basically go for the first round as a written round, right? So in the very first round, they basically try to check for your aptitude, right? So anybody out there who is in fourth year of the college, or I've heard about this, that okay, aptitude is required for clearing some basic companies, some normal companies, so that that's the first round for cracking the interviews and in any companies which basically visit in our colleges, right? Yes, no, right? So Gaurav Singh is saying I'm in second sim. Okay, so you people have must have heard about what all process is there for the interviews for any particular company. So most lower level companies start with the aptitude test, right? They basically go for an aptitude test, and then after, if you clear that particular round, then only they will go for any technical round, either it is coding round, either it is written round for the interviews, or whether it is MCQ round for the technical part, right? So the very first thing is that these FAANG companies don't particularly go for aptitude, right? But these companies surely go for DP problems, right? These companies will surely go for DP problems, dynamic problems, right? Dynamic programming problems, right? And why so? Because whatever the logic, right? Whatever the logic which is required to solve this particular issue or the problem, right? That logic itself capture a lot of aptitude skills, right, along with it, right? Aptitude skills along with it, right? And why is it so? Why aptitude? Because with this aptitude, basically the main focus for asking most of the aptitude question is because they basically go for checking the logic, like how the person is great with the logic, right? So instead of asking aptitude, they basically go for DP, and whatever logic is there or whatever logic is required to basically solve that particular DP problem, that logic itself tells about the interview that okay, this person is really good, he can be a best fit for my company, right? And that's why, I mean, that's why they they won't go for aptitude, and they particularly ask most DP problems, right? And there is one interesting fact about DP, that if you are great, if you are comfortable in DP, right? If you are simply comfortable, right? If you are comfortable in DP, in that case you can basically solve a lot more problems of related to computer science or related to coding aspect, right? Of other part of the coding as well. So suppose you are great with DP, you can easily you can easily understand, or you can easily code the different logics, say of trees, of graphs, of say stack, queues, linked list, of different sorting algorithms and all, right? You will be great with that, right? So most people, like most of the students who are there in colleges, right? They will first start from normal coding, right? So they will start from this normal coding, and by the term normal coding, what I mean is they will simply deep dive into what are loops, what are functions, what are oops, right? And then after they will look for collections or say data structures, right? So they will look for data structures. So in data structures they will generally see stack, they will start from stack, then queue, right? Then I will say hash or hash table, hash function, right? Then they will go for trees, right? And then they will go for graphs, right? I left the one which is linked list. So here you can add linked list, right? So they will go for these topics. After that they will then they may go for algorithms, right? In algorithms also there are multiple things. So initially they will go for sortings and searching. So they will learn sorting, they will learn searching, right? After that they will learn some greedy problems, right? After that they will see some divide and conquer, right? And after that only they will go for dynamic programming, right? And I mean DP or DP, basically they try to learn DP at the end, right? So while learning DP, you already have exhausted your much more energy in these topics, right? In I will say in all these topics, right? In these topics, right? So you have almost exhausted all of your thoughts, all of your logics building in these topics. And if you found that okay, these things are not not much interesting for me, or you see that okay, these things are much more complex for me, you basically when you got to learn DP, right? When you got to learn DP, you are almost exhausted. Okay, I think DP is the most hard problem, because here the most logic building capabilities basically required, right? So you found that, or basically most of the people found this DB problem hard to solve, hard to crack, right? And this is the basic problem. This is the basic domain in which most of the problems are asked in the interview question, right? So we will see today like how to tackle DP problems, how to be great with DP problems, when to start doing dynamic programming and all, right? So see, DB is not alone, right? It basically it is an ancestor, or not ancestor, but there is some concept with that only this thing has populated, or this thing has come into the picture to solve for that particular problem. I will talk about that, but before that let me tell you one more thing about DP. See, if you learn DP, like if I will give you the checklist. If you have learned about the normal coding, like whatever language you choose, if you learn about oops, right? If you learn about I will say basic data structure, if you are only good with array, that will fine, that is fine, right? And you do not know this stack, you do not know this stack, you hash table, linked list, tree, graph, right? Whatever the things you are seeing here, right? Only searching and sorting, this also you can check this out, right? After that you can directly jump to DP, right? You can directly go for DP, right? And why so? Because see, DP consists of very vast problems, right? DP can be implemented for trees, DP can be implemented for linked list, for graphs, for different I will say for stack use. DP can be implemented, right? DP can be there in those data structures also. It can be implemented with those data structures also. But the thing is, DP is not only linked with these data structures. DP also exists, or DP can be also, there are multiple problems which basically require you to have a basic normal coding knowledge, basic array knowledge, basic sorting, searching will also be fine. After that, there is a one topic which is must to know, that is recursion, right? Because after recursion only, right, you will go for DP, right? Why so? Because whatever the problem which we solve in recursion, that same problem, if we want to optimize the solution which is given by the recursion problem, we go for DP, right? So DP is nothing but just an optimization given for recursive problems, given for problems which are basically solved using recursion, right? So DP simply comes with some optimization, right? And today what we will do is we will try to look after some recursion problems, and we will try to use some few lines that will basically convert our entire recursive problems into entire recursive solution into DP solution. Fine. So we will look into that. But before that, if you have any question, you can write it into the chat box. Agree with Gaurav. Any questions so far? Gaurav, we have any question? Sorry, Gurpreet. Do we have any question? I'm not seeing in the chat box, so I'm assuming we have not. Right. Okay, coming back to this DP, right? Why it is required, or why we should start with DP, right? So you saw that why DP is important, or why like what all topics which will be required for going for for these FAANG companies, right? But what why I said that, or why it will be great to start with DP, because whatever, before learning coding, right, you must have heard that coding is great fun to learn, right? It's a great fun to do, right? That have great adventure you will have while coding, right? So all these things, right, all these things you will observe, all this fun, all these adventures, all this logic building, great, I will say great logic building, right? And by this terminology, great logic building, what I mean is you won't be dependent onto some other concept. So the logic will be entirely yours, right? It's just that you need to have the recursive solution for that particular problem, or recursive approach very much clear for solving a particular problem. So on that particular thing, you can basically build up your this logic building, so that you can solve the problem using DP, right? Or you can make the solution in form of DP, right? So all these things can be built up, can be achieved in DP, right? Because we have some real world problems, some live event problem in DP, right? We will see this, right? So it can be there, and you will be also you'll feel that enthusiasm while solving this problem, because it will be tricky, it will be hard to get it, because you won't be able to solve that particular problem if that problem got huge, right? But if you are great with logic building, if you are great with the making the things generic, that how the problem will be solved, I think this is a generic solution. If that is working for the smaller problem, obviously that solution can scale up for bigger problems as well, right? And we will see that this thing will help us, this DB will help us to basically optimize the recursion problem. So the entire logic building will also be great fun for us. Okay, and I'm saying this again and again and again, that recursion is a must if you are going for DP problems, because without DP, I mean without recursion, right, you cannot directly jump over DP and assume that you can solve the problem. Because see, you may see multiple DP solution which can be solved using tabulation, right? Which can be solved by simply using memoization, right? Or that basically, by this terminology, what I mean is you can simply solve your DP problem by just not using recursion, right? But still, I'm saying that recursion is the backbone of DP. Why? Because every problem which we write a DP solution, that has some recursion solution, right? And that recursion solution is just a naive solution. That's a brute force solution for any particular problem, right? So after getting the brute force solution, after getting the naive solution, we basically target for the optimized solution, and that for that we make an opt for recursion plus memoization, or we can opt for direct tabulation. But for deriving the tabulation solution also, you will require recursion as the base part, right? That's why I mentioned that recursion is a must if you are going to start your DP problems or solving DP problems, right? uh, Priya Bharat is saying, Priyanshu is saying that, so how to do strong your logic for coding? Again, I will say, for making your logic really really strong, go for normal coding, right? Learn for arrays, like this is only data structure you will be required to learn, right? Array and matrix. So matrix is just a 2D array, right? If you are good with matrix, I mean these two DS will be fine for us, right? Then try to get recursion, right? And today anyway we are going to see recursion and DP both, right? So if you have any doubt, or if you are newbie to recursion, you will get this whole recursion thing from today's class, right? And apart from that, normal sorting and searching, simple, right? Then directly go for DP, right? If you are comfortable in recursion, then go for DP, right? And how to convert any recursive solution into DP solution, I will talk about this today. Okay, so if you solve multiple DP problems, I will assure you that when later on you will try to learn stack, use, hash table, linked list, tree, graph, you will be comfortable with these different DS thing, because you will already develop your logic building capabilities, so that will basically help you to easily derive the answer for these problems as well, right? So logic building will be really great if you practice DP question a lot, right? So in your initial learning of your coding, uh, as I told you, the prerequisite, it can be of any language. It is not like that what can be done in Java, what can be done in C++, Python, or C, or JavaScript, any language, right? You simply have to pick any language, learn the basic fundamental syntax of it. That's what the normal coding is here. Learn about oops. If you don't know that, that's also fine, because we only require recursion and array and matrix, right? And after that, directly go for DP problems, right? Simply do not pick the DP problem which is related to trees, linked list, or graph, right? Simply do not simply avoid that. Simply check, like, whatever the DP problems which is there, which is given with compared to the real world problems, right? If it is like that, or if it is not relating to any standard data structure, right, where any prerequisite knowledge is required, simply skip those DP part. Simply go for the DP problems which do not have any prerequisite other than recursion, array, and matrix. Fine. I hope this is clear. Priyanshu. Priyanshu is again asking what we to do daily for do strong our logic in coding. See, again, go on Lead Code, right? Go on Geeks for Geeks, right? Simply check out what all the DB problems you have. Start with the very, and before DP, simply go for recursion, right? See what all recursion problem you have, try to solve those problems, right? And if you are good with recursion, then directly go for DP, right? But before that, try to solve at least 50 to 60 question. I mean, 50 question will be more than enough, right? If you solve 50 question on your own, your logic building will be great, and then you can directly go for DP. So you have to basically see which recursive problem needs to get optimized, right? Because we cannot basically optimize every recursive solution by using DP, right? We have to check for the behavior, like, okay, if this problem is, if the solution for this particular problem is behaving like this, okay, now I can, uh, give the solution in DP, and this will optimize the solution, right? So you will have to basically categorize, like, which recursive solution needs optimization and which does not, right? So we will talk about this in today's class, right? Priyanshu is saying, can you give some example for DP problems? Yes, we will see example for DP problems today. I mean, there are multiple things, right? Basically, in DP problems, most of the problems are with the choices, right? So we will see. I mean, what all these things is, right? Choices, right? We will see regarding this. Any questions so far? So let us start with recursion, right? Let us start with recursion. Let us see some problem in recursion, and after that we will try to optimize the solution of recursive solution of that particular recursive problem into DP, right? And we will see why I basically try to optimize this, right? So basically we will see two problems today, right? And we will see like one problem will not require DP to solve it, right? And we will see the second problem will require DP to solve it, right? So let's deep dive into it. Fine. So the very first problem which we are going to see is the factorial one. I hope every one of you are aware of the factorial, right? What is a factorial number? I think like you have learned this in your, I think 11th, right? So we know that, right? If what a factorial number is, if I want to calculate this, n factorial, it will be simply the number multiplying by all its starting from 1 up to that particular number. We have to basically multiply all those numbers. So whatever the answer we got at the end, that will be the answer, right? So we can simply say, right, here is one mistake over here. We need to have this n minus. Okay, that's fine. I mean, that's a generic solution. So we can write here that n factorial is this n factorial is nothing but n into n minus 1 factorial, right? N minus 1 factorial, right? So this statement can be written in this way, right? N factorial is nothing but n into n minus 1 factorial, right? Right. So suppose if I want to get the factorial of say 3, so I can simply say that, okay, for 3, what you do is simply 3 multiply this particular number by the factorial of 2, right? So if you got the answer, please give it back to me. So for 2, again you will have to calculate the factorial. So for this, again I will write key. Okay, for 2, what I will do is I will write 2 into 1 factorial, right? But we already know this is a known solution. This is a known solution that the value of n factorial will be so you know like the value of n factorial for this 0, right? It's 1, right? So we already know, it's already known that the 0 factorial is equal to 1, right? And 1 factorial will be your 1 factorial will be also be equal to 1, right? So I can directly say that, okay, if I want to calculate the factorial of 1, right, I will have to go for 1 into 0 ka factorial, right? So we know the solution of this particular problem, that it is already known the solution of this particular problem is nothing but 1. Now I can calculate this number here. So I will get the answer. It is 1. Now I will go one step above, right? And I will say, okay, 2 into 1 factorial is nothing but I got the answer from here. It is 1. So you can use this, and the answer will be 2 into 1 is 2. So now you will go one step ahead, and at this particular point, you will say that, okay, I have the answer of this particular problem. Now what you can do is you can multiply this. Now you can get the solution that it will be 3 into whatever the factorial you got for this. So here we already got the answer, which is 2. So into 2, and we got the answer. So this is our final answer, right? Final answer, right? So we will try to mimic this same behavior. We will try to mimic the same behavior into our code, right? We will try to mimic this same behavior into our code, right? So let us see the coding part of this. So as of now, I'm using Java, but it's not like the recursion is different for Java, different for Python, different for JavaScript. It's not like that. The logic will be same. The concept will be same, right? It's the generic, I will say, concept which applied to almost every languages, right? Every programming languages, right? Not markup languages and all, right? So what we will be doing is we will be having first of all a main function over here, right? So we'll have a main function, but okay, in main function, what we will do is we will take a number first of all. So suppose say int num is equal to let's have a small number 5. Okay, then we will write a function, right? Or we will write a function so that say result right is equal to, okay, I need to define this. Suppose say int result. So this is equal to say your, sorry, this is Fibonacci, my bad. I need to rename it to factorial. So I can factor, I can rename it to factorial. Okay. So it's factorial, right? So I can simply write here uh, factorial, right? This is a function. And inside this, what I will be doing is I will be passing the number, right? So whatever number I want to get calculated factorial for, I will write it down. And whatever the answer I will get, I will try to simply print it out over the console, right? System.out.println, whatever result I got, I will simply try to print it out. But the problem is I do not have the solution here, right? So what does this basically mean, or what does this basically implies, right? This is basically asking for, can you calculate the factorial for this thing, right? I mean, it is simply asking to calculate the factorial in for this thing, right? So what we will be doing is we will be trying to mimic the behavior of this part into our code, right? So let's check it out. So for here we need to mention it as static integer, say factorial, and suppose it is requiring a number, so let it be n. Fine. And here we will try to okay, so the very first thing is if you see here, if you see this code very closely, that some behavior is getting repeated, right? So whenever I ask you to calculate this factorial, you say that, okay, I'm a lazy person. What you do is, for this particular number, I will choose it, but can you give me the answer of the factorial, which is, one less than that, right? So if I ask you the factorial of 5, so you are very lazy and you are saying that, okay, I have 5, I will multiply it, but before that, can you give me the factorial of 4? If I get the factorial of 4, I will surely multiply that result with 5 and I will return it to the answer, and that will be captured over here, and you can simply print it out, right? So you can see here that whatever function, so this, for this, I basically I wrote a function. I wrote a function like this, factorial, and here I am passing 5, right? So this thing basically relates to this, right? So here what I'm saying that, okay, I need to return a value. I need to return the product. So what I will do is, instead of returning the actual answer, can you give me something like this? Let me code that. Instead of this, can you do something like, okay, return whatever the current number which you are giving me, right, multiplied by, you know uh, I am a lazy person, so what you do is simply go and calculate the factorial of the remaining number, and if you got the answer of the remaining number, give me that. I will multiply it, right, and I will throw it to the place where it is basically required, right? So that's what a simple, this thing will look like, right? But the problem is this is a recursive function, right? This is a recursive function. I hope you are comfort, I mean, you got this right. This is a recursive function, right? Let me know if you don't. Right, you got this right? Okay, okay, fine, great. See, so this is a recursive solution. So what you did, whenever you were asked to give the answer for 5 factorial, you say that, okay, I do not want to do this, I do not want to multiply or get the answer right now inside here. So what you do is, I have this number over with me, you go and try to get the factorial of remaining part. After you got that, please come back to me, I will give you the answer, right? So in this case, what will happen is, we need to include a base condition, because every recursive solution will have two part, right? It will have the base condition, it will have the recursive part, right? So first of all, let us have the base condition. So this base condition will try to stop your function execution. Otherwise your function execution will go in the loop, and you will basically got an error of stack overflow, right? So what we will be doing here is, we will have a base condition. So there's a trick of, there is a trick of writing the base condition, right? So there is a trick, and what the trick is, try to minimize the input, right? Try to minimize the input, right? And solve for that particular minimum input, right? Try to minimize the input, right? And if you got that, right, solve for that, least possible input, right? So what we will be doing here is, we already know that the factorial, we already know that the factorial of 0 is 1. This is already known. And while calculating the factorial, so suppose if I want to calculate the factorial of 5, I will go up to 5 into 4 into 3 into 2 into 1, right? And for 0, I can't go further. Like I cannot multiply 0, right? So 0 is the minimum number which can have over here, right? It is the minimum number which can have over here. So what I will do is I will include that minimum, the minimum possible value of the input into my base condition, right? So the minimum possible value of this input n can be what? 0, right? As discussed. So I will say that, okay, if n is equal to 0, right? Instead of returning the uh, factorial part, I mean, instead of doing this thing, can you simply try to return the actual answer, because I know the answer of this particular part, right? So what you did is you basically tried to solve the base part, and now you write the recursive part, right? So if it is not 0, then if it is any other number, then just I will have a number, and for remaining part of it, simply go over and try to get those number, get the answer of that particular number by yourself, right? So here we will have our recursive solution, right? Or recursive function, right? Right. So now let us try to execute this code and get the solution, like whether it is correct or not. So it is building. Okay, building is taking some time. Okay. Okay, we got the answer, right? So it's 120, right? In output as expected, right? Because the factorial of 5 will be 150. Sorry, 120, right? So now, I mean, this is the whole, flow of writing your recursive solution for any simple problem. So we saw the pseudo code, like how the flow is, like whatever we learned into our, college life, or say in a school life, right? This is the basic logic for calculating the factorial, and this is the basic logic for writing the code for that particular logical problem into a recursive solution. And this base part is really important, because writing a base case is in itself is a difficult part or tricky part, or most of the newbie people get confused to, like, how to write the base part or what should be the base part. So always remember, there's a trick. Simply try to minimize the input and write the answer, because for the least possible input, you already will be knowing the answer, right? So you will have to write it down. So here we can have multiple arguments. So based on the recursive function, we can have multiple arguments. So we will have to make sure that is it like whatever number. See, we do not have to go for minimizing all the input. We have to go for that particular input which is variable, right? Which is varying, right? Varying, right? Which is changing over the time, which is changing by the function call, right? So if I write the recursive function, that particular input will change over each function call. So we only have to handle that particular input. We do not have to handle all the input which I am getting inside this function call, right? So I hope you got this. Which input to minimize, which input to return actual answer for the minimum possible value of that particular input, right? So I hope it's clear. Now let us try to see what will be the time complexity and the space complexity for this particular problem, right? Right. So let us see that part, because that is also important, because whatever the interview you will be giving, right? If it is a DP problem or any problem you will have, for every particular problem, time complexity and space complexity will be asked to you, and you cannot answer like, okay, the time complexity of this particular problem is big O of n, right? You cannot answer like that. You will have to explain. You will have to give the explanation of your particular answer, right? You cannot directly say that, okay, the answer for this particular problem is big O of n or n square or whatever it is, right? You cannot say directly. You will have to give a logic behind it, why it is big O of n if it is like that. Or if you're saying that the space complexity of this particular problem will be big O of n, then why it is like that, right? Can you explain that particular thing, right? So we will try to discuss that part as well. Okay. But before that, any questions so far? Like whatever the recursive solution which we saw. Any question? If you have any question, you can type it over the chat box. Fine. Let me discuss the time complexity and the space complexity of this particular problem, right? So for that, let me. Okay, so first of all, we will look after the space complexity of this, right? Or we will see like how the function call is getting called here, right? So initially, whatever function you call in any programming language, that basically go for that basically go for your stack, right? So let's have this thing. So that basically go over your stack, right? So in stack, basically your main function will be there, right? So inside main, you are trying to call your factorial one. So this fact will be called over here, right? With the input as 5, right? So I mean, first of all, this line will get executed, then this, not this, right? Wait. So this line will get executed, then you are trying to go to this particular function, right? So the flow, the control will move from line number 4 to this particular function, right? And it will go for here. It will check whether the value of n is 0 or not. But the first time, the value of this particular function will start from 5, right? So you will go for 5, and of course this is not true. So this thing part, the code will not get executed, right? So it will say that, okay, I want to multiply this n with some numbers, right? So what it will be saying that, okay, I want to do is I want to multiply 5 by fact of n minus 1, which is 4, right? So again a new function will be called, right? So again in the stack a new function will be called, right? So at this time the function will be called with the input as 4, right? Because we are calling this function with call 4, right? And we will come over here, we will see that this is not true. Then again we are trying to multiply this n. So as of now here the n is 4, right? So it will say that, okay, I can multiply 4 with the factorial. So now can you please give me the factorial of 3, right? So it will say that, can you give me the factorial of 3, right? So after that it will go for, okay, again we will have to go for a function call. So again I will have to go for fact 3. So again here also it will try to multiply 3 with the fact 2, right? So again we will have another function call. So whatever thing you are seeing here is, this is the space of RAM which is getting which is getting consumed, right? So while calculating the space complexity, we will have to take the note that how much the stack basically grows, right? So in that format only we have to tell the answer that what will be the time complexity of this particular problem, right? So here we will be having fact of 2. So for 2 I will be requiring to multiply sorry, fact of 1. So for 1 I will again go for fact of 1. So for this I will be requiring fact of 0, right? So again it will call a function of fact of 0. So when it will call a function with fact with input 0, when this will come over here, right? When this will come over here, what that will get is at this point the value of n is 0. So it's coming over here, it's checking the value. Okay, if it is 0, it is returning some value. It is saying that, okay, can you return directly from here, right? Return from here and take a value one with you. Okay, so this thing, I mean, this function call will get completed, right? So it will come back to this particular function, okay, and this thing will be replaced by the value which this particular thing returns. So this return 1. So this thing will be replaced by 1. So what will be the answer? 1 into 1 is 1, right? So that thing got calculated for this. So this thing will get empty from the stack, right? And this will return a value. That value will be 1 into 1, which is 1, right? So this will get an answer. So this will be 1 basically, right? The value which the very first function returned is basically 1, right? So this will give you the answer as 1. So now you will say that, okay, I can easily say that now I have the answer as 2 into 1, which is 2. So can you return 2? Because I have return statement here, right? So this will again return a value as 2, right? So this is, I mean, this value will be replaced by 2, which is 3 into 2, it will calculate it as 6, right? So again, this will go from here to here with value 6, right? So this will be replaced by 6. So now the value will be 4 into 6, which is 24, right? So this value will be returned, right? This value will be returned. So this will return what? 24, right? So now this will be replaced by 24, right? So this will be like 4 into 24. So what will be the answer? 120, right? So when this main function call the factorial with input 5, it basically returning with an answer, right? And that answer is 120, right? So main got the answer. So this thing got executed properly. The result will get a value of 120. So after that, it will go over here and execute the code, and that will be our answer, right? So, right, if you try to see this thing in much more deep fashion, I mean, if you try to see the actual function trace, so every time when you call a function, right, for each function call, right, what happens over here is, so there is a main block, right? This is the main function, right, when it is called. So here you are writing a factorial, I mean, to get a factorial, right, factorial of 5. So what's happening here is, from this particular block, it is going to some other block, right? So it is jumping, it is basically doing a context switch from one function call to another function call. So in this particular function call, it is having a parameter of 5, right? So in this, it is getting that, okay, can you calculate 5, but I need a factorial of 4. So factorial of 4. So again, this will switch of context, and again the function call will be for factorial 4, right? So it will say, okay, for 4 I need the factorial of 3. So again, this will go for another context switch, and this, okay, this will go for another context switch, right? So this will say, okay, can you give me the answer for fact uh, 3, because this is a function call which happened right now, right? So it will say, okay, can you give me 3 into multiplied by fact 2, right? So this will again go for a function call, right? So it will be fact 2, right? So here you will be saying, okay, I can multiply 2 with fact 1. So this will again do a context switching, and it will again go to the new function call, right? So this will be like this. I mean, this will be simply your, what, 1. So this will be like 1 into f of 0, right? So again, this will do a context switching over here, and this will go for fact 0, right? And this will return a value, and that value will be 1. So you got a value as 1. So this will calculate, this will return something, and if this will return something, this will return something, this will return something, this will return something. At the end, we will get the actual output. So this is what the whole flow of the code is like, right? So if you see over here in this particular recursive solution, we do not require any, any, I will say, uh, any optimization, because the space complexity here is, I mean, the stack which is growing here is, I mean, 1 2 3 4 5 6 7, I mean 7 is there, but we can exclude main, we can exclude 5, we can only go for these thing, right? Because these are the extra space, auxiliary space, which are getting used for solving our problem, right? So we will only go for these, right? Because these are the extra space which are basically used for solving a problem. So with this, I can say, I can easily say that 5 blocks are getting used, right? So I can say that this is my space complexity, but based on data, I will have to say, so if it is n, I can easily, make it generic and say that, okay, the space complexity of this particular problem is big O of n. The explanation of this is this particular thing, right? So you have to answer the question, for space complexity and the time complexity like this way, right? You cannot directly say that the time complexity of the problem is this, or space is like this, right? You have to come up with the actual explanation, right? Actual explanation will be required, in these FAANG companies. You cannot directly, say, because they will be asking you, can you explain the this feature or this behavior? Then you will be stuck, right? So for every recursive problem, try to get the, time complexity, try to get the space complexity, and try to get the detailed answer for that, right? And coming back to the, so this was regarding your space complexity, right? Coming to the time complexity part, right? So if you see here, to solve this particular problem, how many times the particular block of code get repeated, right? So this particular block of code got repeated how many times? 5 times, because this thing got called at this place, this place, this place, this place, this, and this. So if you count 1, 2, 3, 4, 5, 6. So 6 times this code, this block got repeated. So we can say for time complexity, it's n. I mean, it's not n, it's n plus 1, right? It's n plus 1. But for worst case of complexity, we basically go for order, right? The highest order, right? So it will be simply big O of n, right? So I hope it's clear what is the space complexity, basically how to calculate space complexity, how to calculate your time complexity, how to basically, get the recursive solution of a particular problem, right? So we saw that there is no any optimization required for this particular problem. So now the big question is, for what problem the optimization will be required, right? So let us check that as well. So I hope this is clear. If you have any question, you can ask. Okay. Okay, so now let us see like how to basically check for the optimization, right? So for every function call, you cannot create this whole big of stack, right? This whole big of stack. I mean, it's really difficult to create this whole big of stack. So what we will be doing is, instead of that, what we will be doing is, we will try to create the tree of the particular problem, the solution of this particular problem, so, and see, uh, uh, do we like, are we getting any repetition of the code? Are we getting the repetition of the block, this particular block, right? So what will we do is, what we'll be doing is, we will be calculating this factorial. Sorry, we'll be calculating this factorial of 5, right? For this, we require two part. We require n. We already have that, and we have to multiply it with fact 4. So for 4, what we need to do, we again need to calculate the 4. I mean, get 4, multiply with fact 3. So for 3 again, I have to calculate the, calculate the 3 into whatever the fact, 2 is. So this will go on and on, right? This will go on and on, right? So let me clear this part, right? This will go on and on. I mean, again, you will be going for 2 into fact of 1, right? So again, you will be going for 1 into fact of what, 0, right? So this will return you a value. This will return you a value. So after calculating this, you will replace this function call with the value, and you will complete the call. Then you will replace this function call with whatever the value you got over here. So that will be basically, that will basically come over here. So see, you are not repeating a particular function call every time, right? So if there is any repetition, right, so that repetition will be solved using a DP, right? Either we will be using memoization or we will be using tabulation part, right? So I hope it's clear. And now let us look into some problem which may require optimization, right? And we'll be using DP for that. Okay. So let me clear this out as for now. And let me explain the other part of this. I mean, another problem, which is Fibonacci. Okay. So we already know that what a Fibonacci is, right? We all know that, right? So for Fibonacci, it is well known that for calculating the Fibonacci, because there is a function which we have seen so far, like earlier, right? So the function is something like this. So if you have to calculate for Fn, simply calculate your f of n minus 1 plus f of n minus 2, right? And it is well known that f of 0 is equal to 1 and f of 1 is equal to 1. So this 2 is a well-known part, and we have to write a recursive function for this part, right? So what we will be doing is, we will be writing a quick code for this, right? Quick recursive solution for this, right? So let me complete that. So I will write main. So here I will have logic, again same part, num is equal to, say, fib. Here I want the Fibonacci of, say, 5. Okay, or take a bigger number, 9. right? This will be too big, I think. Five is enough. Okay. So if you, sorry, my bad. This will not look like this. We will take a number is equal to 5, right? And we will try to print it out. System dot out dot println. We will call a function fib, and here I will pass the number, right? So this will help me to get the answer, right? And let me have a function call uh, for this fib. Okay, right? So for this n, I have already told you like how to write the recursive solution, right? So first of all, we have to go for the base part, right? So we have to go for the base part. So for base part, what we need to do, we basically need to get the minimum possible values. I mean, go for the minimum possible values. And if you know about those values, you can simply return those part, right? That's it. I mean, so the base case will be, I mean, we already know that, right? So we already know the minimum possible values. If it is 0 or 1, the answer is this. So we'll include these two into the base part. Okay. So for that, I will simply write if n is equal to 0, right? Or n is equal to 1. What you can do is uh, you can simply return n, right? Or you can simply return what? Because for both the case, the number will be 1 because the answer is 1, right? So you can simply return 1. Fine, fine so far. And after this, try to have the recursive call. Now try to have the recursive call, recursive function call. Okay, so this recursive function call will be basically taken from the function call which I have just written over here, right? So it will look something like this. I mean, return fib of n minus 1 plus fib of n minus 2, right? Because that's what I have written over here, right? So if you see here, I mean, that's the solution, right? So if you see whatever the recursive code I write over here, I basically write it over here. Whatever thing I included over here, this basically, include the base part, right? So if I execute my code, right? Let me execute it, run Fibonacci. Let us get the answer. Then we will see like, is there any redundancy here? Any doubts so far in Fibonacci part? Because here we are doing two recursive call. In the previous part, we were basically doing one recursive call. So okay, okay, fine. Let's move forward. Okay, so if you see over the function call, it is very clear that when we are trying to get the Fibonacci of the number, which is say 5, right? I am going for other function call, right? I am going for this function call and this function call. So for this function call, when the value of n is 5, this will be basically n minus 1, which is 4. This will be basically n minus 2, which is 5 minus 2 is 3. So I can easily say that the function call will go for 4 and the function call will go for 3. So this again will go for two function call. I mean, when you call the same code with input 4, it will again do two function call, right? This time it will go for n minus 1, which is fib of 3, and n minus 2, which is fib of 4 minus 2 is 2, right? So this will go for two part. I mean, this will go for fib of 3 minus 1 is 2, and fib of n minus 2 is 1, right? So this will again go for fib of 2, fib of 1. This will go for fib of 1, right? Fib of 0, right? Uh, this will go for again two function call, fib of 1, fib of 0, right? And fib of 1 is the base part, right? So now see what will happen over here is, what are the base part? I mean, what are the base part? I mean, where we will get the output immediately. I mean, this is the base part, right? Because for 1 we already know the answer. This is the base part. 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 This is the base part, right? So for these we already know the answers, right? So this will again go for fib of 1 and fib of 0, right? So these will be including for the base part, right? So this is the base part, this is the base part. But there is a problem. What is the problem? There are few function call which are getting called repeatedly, right? So what all those functions call are, if you see very clearly that we are calculating fib 4. But before that, let us see what will be the flow of code, right? So the flow of code will be, very first, this will be called. After that, 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 this will be called. And if this got resolved, then we will go for this part, right? So it will called after that. So if these two got resolved, then we will go back over here. Then this part will get resolved. 7. I mean, this function will get called, right? If this thing got cleared, then we will go over here. Then this will get executed. So I mean, this function call will happen. So from here, this function call will happen. After that, this function call will happen. After that, I mean, this basically completes this part. So now what will happen is, now this function call will happen, right? At this particular time, right? After that, this will be called. After that, this 13, this will be called. After that, this 14 will be called. After that, this, now I mean, this will get returned over here, this will be here. Now after that, this 15. So we saw in total 15 function call, right, will happen for just calculating the Fibonacci of 5, right? But the problem is, whatever the function call which we are making, we are basically repetitively calling the function call, because fif 3 is getting called over here and here, right? If you see fif 2 is calculating over here and here and here, right? Anywhere else? No, right? So multiple, if you see multiple a function call which are getting called, right, which we already know answer of, right, or which is basically called off, right? So what we will be trying to do is, instead of calling the same function again and again, right, what we'll be doing is, we will be saving the nature of it. I mean, if I have calculated the fib of 3 one time, I will not again calculated the Fibonacci of that particular number, right? I will not again go for the function call for that particular number if I have the answer, right? And that's where DP come into the picture, right? That's where DP will come into the picture and will say, okay, from this 15 function call, what I can do for you is, I can make this thing happen in only 5 function call, right? So this is what the great optimization will be seen, whenever you will be using DP into your program, right? So you saw there is here it is exponential, and here it is linear. I mean, if you include the DP part, the time complexity will be simply big of n, rather than the exponential solution, which we will be getting into the very first case, right? Fine. Any doubts so far? Right now you got the gist, like where DP will come into the picture. Right? So now let us try to solve this very same problem with a little optimization, and we will be trying to make sure that instead of this big tree, it will make only 5 function call, right? Or minimum possible function call, right? Let us see that part. So for that, what I need to do is, or what we need to do is, we basically go for dynamic programming. And for dynamic programming, what I will be doing is, instead of directly going for the function call, I mean, uh, for the for the recursive function call, I will try to save the part. I mean, I will basically try to save the code basically, right? If I have calculated for that particular part. Cool. So for that, what we can do is we can directly go for we can have a on an array, right? And for that particular array, what we will be doing is we can store the solution, right? We can store the solution into an array so that every time sorry, next time if I am calculating the function, I won't have to go it for the second time, right? I won't have to go it for the second time. Or apart from that, we can directly go for we can directly go for the for loop, right? So here what I will be doing is, instead of this, I will create a variable, suppose say int, right? So this is it, right? So as of now, let us okay, sorry, this won't come over here. Let us try to use this try to solve it using a normal array. I mean, simple memorization using simple dynamic programming, right? So for that, what I will be doing is, instead of writing this function, I will comment this out, right? And I will write some other function. Okay, static uh, integer, then Fibonacci, right? And this will accept integer. Okay, so suppose it is n, fine. And for this particular thing, what we require to have, first of all, an array, right? So this will be nothing but your new int, and you can pass the size, that can be basically your n plus 1, or let us take 2 for the safe side, right? Initialize an array, right? Then try to and we already know the solution for a few of the numbers. I mean, we know the solution for 0, that it is already 1, right? We know the solution for 1, which is equal to 1, right? So this solution are known already, right? For remaining part of the solution, what we'll be doing is, we will be going for an iteration, right? Int I is equal to 2, right? Simply I less than n, right? Then I plus plus, right? So here, what we'll be doing is, we'll be calculating for that particular part, right? I mean, the same I did for the recursive part, right? Here also it will be same. Okay, minus 1 plus f I minus 2, right? So that's it. And at the end, what I need to do is, I simply need to return the f of n part. I mean, the last index, the answer will be stored basically in the last index, right? So anywhere, I started from 2. Why so? Because I already know the answer for I is equal to 0 and I is equal to 1, right? So that's why I will not go for I is equal to 1 and 0 in this loop, right? So at the very first time when this will try to execute, this will try to get for, we know the f of 0 is 0. We know the f of 1 is 1. So if we need to calculate for 5, it will go for, first of all, it will calculate for f of 2. So that is f of 0 plus f of 1, right? I mean, from here, right? So we know the answer for this from here. We know the answer from this from here. So it will be calculated as 1. In second loop, it will go for f of 3. For that, it will go for f of 2 plus f of 1, right? And we have already stored the answer, right? For this, right? At this particular index, right? And for this, I mean, it is 1 and it is 1. The answer will be 2. Then it will go for f of 4, which will be nothing but f of 3 plus f of 2, right? And we already know the answer of this and this, which is 2 and 1, right? So I'll be doing 2 plus 1, right, which is equal to 3. Then it will go for f of 5, which is f of 4 plus f of 3, right? So this way, this whole function trace will go for, right? So I hope this give you a wide picture, like how why, like how it is similar to recursive solution, or how you can go for the DP solution, or why it is required, right? So if you see in this particular thing, the time is got optimized a lot more, and this case time is getting executed end time. So what is the repetition of this particular part? We can simply take that part into our time complexity consideration, right? So it is only for 5 problem size, the part which is getting repeated is only 3, but it is somehow similar, I mean at near to n, right? Because if you pass 100, the loop will execute I think 98 times, right? So it is similar to this. So we cannot say big O of n minus 2, because we have to go for the higher order, so and remove the constant, so we will go for directly n. So this will be the time complexity. And space, extra space is required here is the array which you are using, the auxiliary space you are using for storing your previous state information. So the space complexity for this particular problem will be big O of n. So both time and space complexity for this particular problem will be big O of n, right? So I think this give you the wide picture of at least to start, from where to start your your DP part or your recursive part, right? I think the basic building block of this recursive part and the DP part, I hope it's clear, right? I mean, if you have any question regarding this, regarding DP, regarding recursion, you are free to ask. Okay. Okay. So coming back to again this FAANG thing, right? So remember, right? Focus on time complexity, right? Time complexity of the problem, right? How to calculate it, right? Focus on space complexity, right? Space complexity, right? Focus on recursion, right? Because this is a little tricky, right? This also build your logic, right? A lot while solving a problem using recursion, right? Go for after this you can go for DP, right? Then again the logic will be great over here. So these are the basic questions. I will say the repetitive questions which are asked multiple times or a lot. I mean, whatever question you write, or whatever whatever question you will be asked in these companies, in the interview of these companies, this, the topic which I discussed today, or the topic which is mentioned over here, from this topic question will be there in every round of interview, right? I'm not saying a single round of interview, I'm saying in every round of your interviews, right? So it is a must, right, to have a knowledge of these particular topics, right? So I think that sums up for today's session, right? The topic which is important, the basic of it, how to start of it, right? So uh,
Thank you so much, sir, for the informative session. And dear participants, we are now open for the Q&A session. If you have anything to ask, you can put it out in the comment live chat there. Sir will be taking personally. Sir, I guess we can wrap up now. We don't have any questions on YouTube chat. So once again, thank you so much, sir, for connecting with us today and giving your valuable insights to our dear participants.
Yeah, thanks a lot.